In Lecture 5, we're going to talk about weathering and mass wasting. But before we talk about those, let's talk a little bit about sedimentary rocks. We're going to talk about sedimentary rocks for a couple of reasons. First of all, because we have to talk about something that's going to be weathered and mass wasted, some sort of rock. And weathering just happens in place, so rocks are broken up in place, and mass wasting just means they kind of go down a slope or go down a hill. But to start with sedimentary rocks, one of the reasons we'll talk about them here is because after rocks undergo weathering and mass wasting, and then maybe they're transported by a river or a glacier or waves in the ocean, and finally they're taken to a place where they're deposited and they're cemented together as a rock, the type of rock that results from that is a sedimentary rock. So sedimentary rocks, here's an example here showing the Grand Canyon. And the Grand Canyon is just layers after layers of sedimentary rocks. And we can see some that are very resistant and forming cliffs, like in this area here. And then we can see some other layers of rocks here and here that are less resistant, and they're forming these slopes that could potentially be walked down. They're not sheer cliffs. All of these were deposited by little broken up pieces of other rocks, and that's how sedimentary rocks are formed. There's two major types of sedimentary rocks, and the first we'll talk about is clastic sedimentary rocks. So a clast is just a little broken piece of something, and in this case the clasts are little broken pieces of other rocks. So we could start out with an igneous rock or a metamorphic rock or another sedimentary rock, break it up into little pieces, and that would give us the sediment. Once we have that sediment, it can roll down a hill, but it can also be transported and deposited by wind or rivers or glaciers or waves, and then it can be compacted and cemented into layers. So let's talk about what type of clastic sedimentary rocks we have. This is just a chart showing how we name those. I've kind of whited out the one we don't need to worry about here, but one thing to notice is there's a couple of things going on in this chart. The grain size is going up from the bottom to the top. So here we have very fine grain, which means mud sized. We have medium grain, which means sand sized, and we have coarse grain, which means gravel sized. The other thing that's going on is for the gravel sized, we have rocks that are made up of well-rounded pieces of gravel and angular pieces of gravel. We give those two different names. But let's start in the middle here with sand, and how once we make a rock out of it, it's made into sandstone. So we see sand whenever we go to the beach. The sand is just describing the size of the particles. If we see very white sand like this, probably most of those particles are quartz grains, so little broken up pieces of quartz. They tend to be on beaches because they're hard, they last longer, while other rocks get just broken down into mud-sized particles. Quartz is stronger and can stay sand size for longer. And then if somehow over time this beach gets buried and the sand gets cemented together and turned into a rock, then we would call that rock a sandstone. So here's an example of a sandstone here. If we felt it, it would feel coarse like sand, like sandpaper. And if we looked at it with a little lens or put our eye right on it, we would see all of these particles making it up are just sand-sized particles. We can also see some fine layers in it. That might be just the layers of sand that were laid down over time on the beach or other environment. When we talk about things like sand and also gravel, we talk about two things: how rounded the grains are and how well sorted the grains are. So for a grain to be round, it doesn't have to be a perfect sphere. It just has to have all smooth edges. So we would say these two are angular grains. We would say these two are intermediate, and we would say these two are well-rounded grains, even though one looks like a sphere and one's more like a pickle. The other thing we talk about with sedimentary rocks that have either sand or gravel-sized particles is how well sorted they are. So if all the particles are about the same size, we would say that's very well sorted, and that would be like the sandstone we saw in the last image here. All these grains look about the same size, so we would describe that as well sorted. Moderately sorted, we're starting to see some bigger grains and smaller grains, and poorly sorted, we get some very big grains and some very small grains all mixed together. And when we go up to the gravel-sized rocks, this is how we tell the difference between the two of those. The one that we call conglomerate has rounded gravel in it. So we can see how nice and rounded all of the pieces of gravel in it are. Even though it's poorly sorted, we see really big gravel, there's some sand in here, there's some mud in between, all different sizes of particles are in this rock. So we would describe this as poorly sorted, but well-rounded. And that's different than the breccia. So the breccia has angular fragments in it, as we see here. So we would describe this as a breccia, B-R-E-C-C-I-A. And the breccia is also poorly sorted because we have mud and sand and big grains of gravel all mixed together here. But we call it a breccia instead of a conglomerate because the ones we can see, the gravel-sized particles, are not well-rounded at all. In fact, they're very angular. So angular gravel in a rock we call a breccia. Rounded gravel in a rock we call a conglomerate. If we have mud-sized particles, we can't actually see the particles themselves. Sometimes we can see little thin layers, almost paper-thin layers here, and those are the layers associated with the mud that was laid down over time. This is probably not a beach here. This might be more like a swamp or a delta or something like that. And as these layers of mud are laid down over time, they're buried and cemented together into this rock. And we call this kind of rock with clay or mud-sized particles a shale.